Here's an example of graphing a parabola from the perfect square format. The nice thing about perfect square format is it tells us instantly what the vertex is by transformations. This -3 is moving the graph of a parabola 3 units to the right, and this -4 is bringing the parabola 4 units down. So we know right off the bat that our vertex is going to be 3, -4. So the work involved here will be looking for the x-intercepts and the y-intercepts. We'll start off with the easier one, that would be the y-intercepts. And to find y-intercepts, all you have to do is let all the x's equal 0. So this becomes f of 0 is equal to 0 minus 3 squared. Don't forget that, minus 4. A lot of people, when they do this, they forget the square and make a mess of things, so be careful with that. This becomes -3 squared, and -3 squared, by the way, is 9 minus 4, and we get this value of 5. So we know for sure that f of 0 is equal to 5, which also is the y-intercept, 0, 5. Alright, to find the x-intercepts, sometimes it takes a little bit more work. Sometimes it's really easy. Here we're going to let y equal 0. In other words, the function notation f of x, we're going to replace this whole thing with 0. So we're going to get 0 is equal to x minus 3 all squared minus 4. Now it is not necessary to square out x minus 3 and get x squared minus 6x plus 9. That actually makes it a lot worse. It's easier to solve this as a perfect square equation. We'll move the 4 to the other side and then square root both sides. Alright, so add 4 to both sides and you get 4 equals that x minus 3 all squared. And then we're just going to square root both sides. So we'll square root this side, we'll square root that side, and the only thing you have to remember is when you square root both sides of an equation, you have to add in that plus or minus. In this case, square root of 4 is 2. So we'll just get this plus or minus 2 is equal to, and on this side we'll just get plain old x minus 3. And then we just have to add 3 across. So we're going to get x is equal to that 3 we added across. Try to keep this plus or minus in the middle. So we get plus or minus 2. Alright, and then the two answers are going to be 3 plus 2, which is 5. And we got this answer by letting y equal to 0. And 3 minus 2, which is 1. And we also got this answer by letting y equal 0. Alright, so this gives us our vertex, our y-intercept, and our x-intercepts. So the next step is to plot our information here, our vertex, our y-intercept, and our two x-intercepts. Alright, let's start with the vertex. It's 3, -4, so that's 3 to the right, and 1, 2, 3, 4 down. So we'll plot a point here. We have 0, 5, which is nowhere, and then up 5. So we'll get our y-intercept there. We have 5, 0, which is 5 to the right, and 1, 0, which is just 1 to the right. So this gives us our 4 points that we've just discovered. Putting this into a better picture, we have this. Now, the 5th point, sometimes we only get 3, but in this case we'll get 5. We have to remember that straight down the middle here, we have this axis of symmetry. That means the parabola is symmetrical over this, reflected over this. So this point here, this y-intercept, is 3 units away from this axis of symmetry. That means there must be another point of the parabola 3 more units away right here. And this will give us our general shape of a parabola. And we get a graph that looks something like this, where the red dot is that reflected point over that axis of symmetry that goes right through the vertex. And this would be the graph of f of x.